right, so I'm live with episode 6 of 52 weeks of AWS, and today I'm going to finish up the AWS Cloud Practitioner material. So this should be a good summary of the last sections of the exam, and this AWS Cloud Practitioner exam is something that I've taught students, maybe thousands of students all over the world, maybe more than that, this material. And in general, I would say it's great for people that are new to AWS, and I would recommend starting with the Cloud Practitioner certification. Before I get to that, what I will do is also show you a little bit of stuff I've been working on with AWS. And after we get through the Cloud Practitioner material, I'll probably maybe take a couple episodes and dive into some coding in multiple languages like Go or C# or Swift, Bash, and show some things. And then I'll go into the Solutions Architect certification after that. So the idea here with the podcast is to just really share what I'm working on each week and incrementally let you level up. So maybe to start with, I'm going to share my screen here. And here we go. Share the screen. And I'm going to go to a window that has some of the recent material that I've been working on. And in particular, one of the things I was working on this week is the .NET and AWS ecosystem. And one of the things that I would recommend starting off with, no matter what language you're using, is to try to do things in the Cloud Shell first. And so I have an example here where I show some of the things that you can actually do from the Cloud Shell. And what's awesome about the Cloud Shell, and let me actually just put this to the side as well so I can follow along on my own. What's nice about the Cloud Shell is that it's probably the quickest way to play around with an API, much quicker than doing things with another language. And I'll show you what I mean. So you see this example here. I can just copy it and I can go into a Cloud Shell, just click this button, launch a Cloud Shell. Now it takes 30 seconds or so to spin it up, but really I've found it to be one of the best ways to explore an API before I get into Python or C# or whatever language I'm using. And in particular, one of the things that I'll show you is if we go to Google here and we just type in AWS CLI, you can see that there's a whole list of different things that you can do here. But in general, the idea here is that there's a command, and then there's an option, and then there's resource identifiers. And in particular, here's a good example, AWS EC2, describe the instances, or publish a message. It really is the most efficient possible way to do anything in AWS. So, if we go back here and just let this thing refresh, it should be ready to go. I can run a comprehend command. So the way I'm going to run this command is I'm going to start off with AWS, do a sub command, which would be the name of the service. The comprehend service is the natural language processing AI service. And then I'm going to use a sub command, which allows me to run a component of that service. So if I just paste in here, AWS comprehend detect sentiment, I like to do these backslashes for each of the lines so that it's easy to read and share the code with other people. So when I do this, the AWS Cloud Shell will go through and it'll ask me what I want to do, and I'll go ahead and paste this in. So once I throw this in here, it'll come back with a JSON payload that has the sentiment as the key, and then the value of that sentiment as the value, and then sentiment score would be the key, and then it also contains a dictionary of the positive, negative, neutral, or mixed values. So very, very easy to play around here. And if I do up arrow, I could change things around and say today is very chilly, but I love today, or I don't know, something like this, and it says mixed, right? And so, in general, the idea here is that prototype things out using the Bash terminal. And in fact, I think one of the examples they showed which I can actually go to, is if we want to type in AWS EC2 describe instances. Very straightforward, right? Like it just is, in my opinion, the most efficient possible way to do anything on AWS is to use the shell. So just kind of a pro tip there. So once I got that going, one of the things that I did, if I go back to this example, was that I did a sudo yum install links. And this is a pretty cool little technique to be aware of, especially if you're into data science, is that links is a command line browser. And so I'm going to go back to the Cloud Shell environment here, and I'm going to do this. I'm going to say sudo yum install links. So let's go ahead and do that. And the reason I run sudo would be that it would elevate the privileges. I would do install links with yum, and the yum is the package manager that works with the Amazon Linux 2, which is what Cloud Shell is running. I'll say yes. There we go. And once I've got this installed, then if I go back to my instructions here, we can actually start to read other websites by running the links command and then dump. And this will actually just dump it out to the terminal. So in this case, I'm going to look at Albert Einstein. Here we go. And we go through here. We say, great, Albert Einstein, and I just paste it out. And so if you're doing some data science and scraping, this might be one of the coolest ways to scrape with the Cloud Shell. And there we go. And I can, look at things. Now, one thing to be aware of is that I could assign the output of this operation. Let's say if I use the head-c 5000, that would give me the first 5,000 bytes, which conveniently is all that the command line tool from AWS Comprehend will take. So I dump that out to a variable, and then what I can do is I can actually paste this code into a whole sentiment analysis detection. So if we go here, I can go through here and I can do sentiment analysis detection, and it's going to go through here and it's going to say, there we go. It's a neutral score, but there is a lot of positive weight here. So definitely try out doing some stuff with Bash, and using things like links alongside Cloud Shell. Great way to do things with AWS. And further, if you want to do something really tricky, I have an example here where I detect entities, and I allow you to go through here and build out a very sophisticated pipeline. In fact, let's just go ahead and run that. And so if we want to, I can just go to this snippet, paste it in, and I'll just walk you through what it does. So basically, I say AWS Comprehend detect entities. So grab the entities out of some payload. I say -- language English. I do text equals text. So that's that payload I pulled from links. And then I say I want to output the results of the extraction. And then I use a traditional Bash pipeline here where I cut the fifth field. Then I go through here and I only grab the alphabet characters. And then I go through and I take the upper to lower. And then I get rid of new lines. I sort it. I do a unique. I then do a reverse sort. And then I look at just the first few items. And what this gives me is that I now have the entities that are extracted, cleaned up, that are probably the most important for those 5,000 bytes that I had. So I can see, Einstein, there's 12 of them, right? So if I was just blindly, scraping tons and tons of websites, this would probably give me a very, very good idea of what this Wikipedia article was about, right? Well, it's about Einstein, right? So there's 12 instances in the first 5,000 bytes. There's 6 instances of university. There's German, Empire, Albert, so really, really neat way to interactively do things from the command line. Okay, so that's probably a good enough snippet of some of the things I'm working on, and you can go to this repo yourself, which is NoGift inside of GitHub and .NET AWS Comprehend. And you can even look at a C# example I have here as well, where I go through and I build some stuff in C#. But I'm going to move on now to the final part of the Cloud Practitioner material. And what I'm going to cover is starting We already covered, I believe, the 7, which is storage, last week. So I'm gonna do these last 3 modules, starting with module 8 here, which is databases. So let's go into this databases and talk about how they work on the AWS platform. So to start with, we're going to talk about the RDS system, which I've used in production many times. DynamoDB I've used in production, Redshift, Aurora, and let's go ahead and dive right into it. So Amazon has a relational database service called RDS, and what it does is it allows you to forget about some things that are really annoying. And in particular, when you have an unmanaged system, you have to scale the load yourself. You have to develop the fault tolerant system, like client server relationships, horizontal scaling. You have to do backups, and I've been badly burned in my life. Every time I've worked at organizations, even when I was in charge, I've still made mistakes when databases are unmanaged. I've had much more success with managed databases because they can do the scaling for you. In fact, with Amazon, I remember one time I was in the Bay Area and I walked up to the headquarters of an office and I literally clicked a button while I was inside of Amazon to upgrade my own database in production because it had problems. And it literally took 2 minutes and was like, went to a bigger instance. So there's a lot to like about the RDS system. So the challenges of a relational database is the maintenance, energy footprint, software installation, packages, database backups, HA or high availability. There's limits on scalability, right? Because eventually you'll run out of the ability to vertically scale it. Data security, and then also the patching. It's very easy to get some security hole in the OS. With RDS, though, it manages the service for you and allows you to address a lot of the challenges of an unmanaged standalone relational database. It allows you to focus on application. And so you can give the applications the performance, high availability, all the stuff that comes with RDS. So in the example from on-prem to Amazon RDS here, you can see that they're on-prem. There's a lot of stuff you have to do that you really don't want to do. In fact, I've done many of these things in my life, and it's actually very annoying. But when you go to EC2, really Amazon provides like patches, OS, rack and stack servers. But then when you go to RDS, what's nice about it is that because it's specifically designed, the snapshotting gets taken care of. So I would say just snapshotting and scaling alone are some of the killer features, but it also has the ability to do high availability deployments by using multiple AZ based RDS, which means that you can put these in different physical data centers, so you don't have to worry about there being downtime. So manage responsibilities. This would be you would manage things like the application, and then the AWS manages the installation, patches, database software, high availability, scaling, power and racking, stacking, server maintenance. So I would find it very difficult for someone to justify at a more of like a Fortune 500 level managing their own database. You would have to have a very good reason, in my opinion, just because of the advantages of using something like RDS. So in the case of RDS database instance here, there's things like CPU, memory, network performance, and then the storage, magnetic SSD, IOPS. In the old days, before SSD was available, one of the biggest bottlenecks with databases was the spinning disk was really the kiss of death for a database. And it's amazing how just moving to SSDs has really dramatically improved the performance. So how would it work in a virtual private cloud? You would have a public subnet where your EC2 services would live, and then the private subnet, so no one can access it. You don't want people talking to your database directly. That's a big no-no. Instead, you have the private subnet connected to the EC2 instance, and then when people access your web service, they're never directly talking to the database. In an HA setup or high availability setup with multi-AZ or multi-availability zones, what happens is that you have the RDS instance synchronized also to a private subnet, and this allows you to basically have this thing on standby waiting for an event where it needs to be triggered. Now, another example here would be that you could also have things automatically fail, and DNS could would not even need to be addressed in this scenario. So one of the things that's you're able to do with RDS read replicas is that you can offer async replication, and they can be promoted to primary if needed. So this is a very traditional way to scale out basically horizontally, is that you have read replicas where all the read operations go to it. And what happens is many times the bottleneck on a system is actually the read. I mean, sometimes it's a write, but in general, this allows you to create the read replicas in a different region than the primary. And then this really goes over things like disaster recovery, because if the primary goes down, you can just promote the read slave, basically into the system that you need. Okay, so you use cases here. There's web and mobile applications. This would be high throughput. They have e-commerce applications. That would be a low-cost database. Mobile online games. These are all examples of those. So when would you use an Amazon RDS system? Well, I would say complex transactions or complex queries. Right, a medium to high query system. You don't have more than a single worker node. You want high durability, but when would you not want to use RDS? So if you have massive read writes, so like 150,000 writes a second, I mean, that's a lot of writes. And you have sharding due to high data size. You have very simple operations, like you're just basically putting data in, pulling it out. And that's more of a NoSQL use case. Or if you have a bunch of customization for your database. So the way it works with RDS is your build clock hour billing, and you also have to consider the characteristics. So engine, size, memory, right? So do you want to use MySQL, Postgres, SQL Server is another option from Microsoft. So what are the different purchase types here? You can do on demand, which is much more expensive. I think, especially if I can think of one of the most common mistakes a company would make, is to use their databases as on demand, because maybe for the first 3 months, as you're figuring out your capabilities and how much people are hitting your site, but really you should do a reserved instance for a relational database system, because you should know what the characteristics are in terms of performance, and you're paying much more money if you use on demand. Also, in terms of storage, you have provision storage, and you also have the ability to have backup storage. And in particular, one of the things you can do as well is you need to know about the input and output requests made to the database. And there's also storage and IO charges that are different depending on what kind of config. So if it's a single AZ, which is not recommended, you don't. There are not as many charges as a multi-AZ. So the multi-AZ, you are charged basically because of the requests that are being made, and so you should be aware of some of those additional charges. But for data transfer, there's no charges for inbound, and there's tiered charges for outbound. So we'll kind of skip through some of this lab material, but basically RDS is I think a great service for most corporations that are using cloud computing, and for startups. So DynamoDB, the idea here between a relational or non-relational does go back to something called the CAP theorem, where you have a trade-off between characteristics of a database like consistency or availability, or partitionability. But in this particular example, they show that there's rows and columns in SQL, but non-relational is key value. So you can think of a NoSQL database a lot like a giant JSON serving server, right? So where you have key value pairs, and you put the JSON inside and you pull the JSON out. So why would you want to use it? It's fast, flexible. I can't tell you how many startups I've worked at that use either Mongo or DynamoDB. Key value, the reason people like it, it's just very easy to use, unlimited storage, because it's a distributed database, low latency queries, scalable read writes. So some of the things to be aware of with Dynamo: tables, items, attributes are the core Dynamo components, and they support a couple different primary keys. There's partition key, partition, and key sort. And so as the data grows, the table is partitioned by key, and you can query the key to find items, or you can even scan. So you can scan the entire database. I don't think that's really something you would want to do at scale, but in some situations, a scan is actually a reasonable thing to do. So items in a table must have a key, and that's really the secret sauce for a key value database. It can either be a single key or a compound key. And so the compound key would have a partition key and a sort key, for example, and attributes. And so in terms of DynamoDB, in fact, I'll just show you real quick, since I already have AWS open here, that it's surprisingly simple to use DynamoDB. To use it, you just click on it, and it's almost like Google Sheets or something, in my opinion. You go to tables, and you just click on create table, and we just say 52 weeks like this, and we just need to put in some kind of partition key. I like to say, I don't know, globally unique ID, right? That's one way we could do this, and just click create. That's it, right? So it's really just a couple clicks of a button, and then you have a database that's going to be created for you. And it's actually very quick. Even it's actually, I think, creating a table, you can see how quick it is. It's like 10 seconds. And once you've got this set up, all you need to do is you can actually go through here and create an item. And then in the item, we can just say, like, I don't know, 1, 2, 3, 4, and there we go, right? And basically, because a globally unique ID is the key, we would just put in a bunch of globally unique IDs, and then we could populate it and then do whatever we wanted to it. So very, very straightforward to build things using the DynamoDB interface. Okay, so let's talk about Redshift. Redshift is definitely a different beast. One of the things that's interesting about it is it's a data warehouse, so columnar store. And in particular, if you need the heavy lifting of doing things in a data warehouse, it can be very cost effective. And so it has the ability to do scalability automatically as well. And with Redshift, it has connections to many different SQL clients and BI tools. So that's one nice thing about it. So it's really an enterprise data warehouse. And so it's low price for small customers, and you can scale it up as needed. And it's also another use case for it could be like a SaaS. If you wanted to scale a data warehouse, add analytics function, right? It would be pretty straightforward to do that with Redshift. Okay, Aurora is kind of builds on top of RDS, and it's a enterprise class relational database, and it enhances some of these open source tools like MySQL or Postgres. It automates things like backups, provisioning, and so the benefits of Aurora are it's a managed service, it's fast, available, simple, pay-as-you-go, compatible. So it's really like a kind of a jazzed up RDS. And so with the Aurora system, you can do things like have 15 read replicas, which is pretty amazing actually, because it extends what a traditional MySQL Postgres database can do. And so it's got resilient design as well. So it doesn't need to have, basically checkpoints. It's already done this automatically for you. So basically it's a high performance system, high availability, multiple layers of security, but it fits in with the MySQL or Postgres, compatibility, and it's fully managed. So when would you want to use the what tool for what job? So enterprise relational database, use RDS. For fast, flexible NoSQL, use Amazon DynamoDB. For operating system access or application features that aren't supported by AWS, like you have a custom database you need to manage, you can just set that up on EC2. Or if you have a specific case-driven requirement like ML or data warehouse or graphs, like The graph databases are something I've used in production. You could use an AWS purpose-built database service. So there are additional databases on AWS, like their graph database, for example. So I think this is probably a good place to move on to the next section. And I'm going to talk about, in section 9 here, cloud architecture. So we're really getting to the end of the Cloud Practitioner material. And so what we're going to talk about is the well-architected framework. And in particular, the well-architected framework is something that you'll see a lot, in documentation about consulting or whatever. And the idea is that there's essentially like a checklist, right? Where you're telling people what it is that you want to build, and you make sure that they're doing it in a correct way. And so one example they're bringing up is it would be a lot like building architecture. So what is it? It's a guide for for designing infrastructures that are secure, high performant, resilient, and efficient. And it's a consistent approach. So it's not like somebody has a different opinion each time. And it's a way to provide best practices that were developed through the lessons learned from reviewing other people's architecture. So I think this is a very good idea, is to have a checklist where you have standards of excellence. So what are the pillars of the AWS well-architected framework? We have operational excellence, we have security, reliability, performance, cost optimization. And so let's go through here and take a look at some of these. Identity and access management. This would be how to manage credentials and authentication. One of the biggest, I would say, problems with people setting up AWS is that their API keys get put somewhere, like the root keys get put into GitHub, and then someone takes over the account. Very, very common problem. Other things like password requirements, credential rotation, MFA or multi-factor authentication. These would all be things that you could go through with a well-architected framework and address. So, they go through here and talk about some of these companies that you could actually go through. I can let you go through that on your own. Now, in terms of operational excellence pillar, this would be how to run and monitor systems and make sure that they're actually serving the requirements for your organization. So what are the key topics? Automating changes, responding to events, defining standards to manage daily operations. And so some of the design principles include perform operations as code, make frequent, small, reversible changes, refine operations procedures frequently, anticipate failure, and also learn from events and failure. So I think this is something I've seen in the real world quite a bit, is that you need to figure out why things are failing and actually improve things. So this is the concept of Kaizen, which you'll hear a lot in DevOps, is continually make things better. So you need to monitor what's happening to identify how you can make things better. And then in terms of operational excellence, we can look at, how do you determine what your priorities are? How do you structure your organization to support business outcomes? How do you design your workload so you can understand its state? How do you understand the health of your workload? How do you evolve your operations? All really good questions to consider. Okay, security. One of the most important ones of any system. How do you protect information systems and assets? How do you protect confidentiality and integrity of data? Identify who is doing what? Protect your systems. Establish controls to detect security events. So, this means implementing a strong identity foundation, traceability, security at all layers, automate security best practices, protect data in transit and at rest, keep people away from the data, and then prepare for security events. So a few questions in security, that you could ask an organization is, how do you securely operate your workload? How do you manage the identities of people and machines? How do you detect and investigate security events? I mean, that's a pretty basic one there, is that if you ask an organization, how do you detect, breaches in your organization? And they say, what's that? Well, that's a bad sign, right? Because you could have a lot of issues that are happening. Now, how do you protect your network resources? How do you protect your compute resources? How do you classify your data? These are all really important things to be aware of. Okay, reliability. This is making sure that your workload performs its intended function and consistently, right? So if your system isn't functioning because there are scale issues or there's software deployment issues, you don't have a reliability, and so you need to design your system. So you need to be able to design your system to recover from failure automatically, and this would be, for example, a load balancer. That's one of the core features of it, is that it can detect a health event and take that instance out and put another one in. Also recovery procedures, how to scale horizontally, right? This is a very common problem, is someone sets up AWS and they don't have a auto scale group set up. So the machines can't scale, even though it's fairly simple to do. And so this means stop guessing, capacity, manage change, and automation. Reliability questions, how do you manage the service quotas? How do you design your workload? Service architecture, how do you monitor what's going on? Failure, there's a big one, is how do you back up your data? How do you test that the backup is actually working? How do you plan for disaster recovery? In my opinion, if you care about backing up your data and you don't test or restore on a periodic basis, you're just asking for problems. And I've had this happen in real life as well. So performance, basically use IT and compute resources efficiently. So you don't want to be spending $100,000 a month on Amazon when it could be done in 1,000, right? That would be wasting your company's resources. And so this would mean democratize advanced technologies, go global in minutes. So you don't need to be managing your own global data centers. You can just use the global data centers that are available in AWS. Also, serverless can be a huge win. I'm a huge fan of serverless because it makes things, in many cases, more efficient to build solutions, experiment more often, and consider mechanical sympathy. So what that means is use technology that aligns best with what you're trying to achieve. So what are some of the performance efficiency questions? How do you select the best architecture? How do you review the best architecture? And also, how do you monitor resources to ensure they're performing? And how do you use trade-offs to improve the performance? Cost optimization, so avoiding unnecessary costs, key one. Make sure you have a consumption model, which is you pay for the resources that you require. You have ability to measure the efficiency, so you're measuring the business output of the workload and the costs that are associated with it. You stop spending money on undifferentiated heavy lifting. So basically, if you're doing stuff that you don't need to do, just stop spending money on it. For example, managing your own data center, and then analyze and attribute expenditure. So see who is generating the expenses so you can figure out if it's actually required or not. Some of the questions, how do you evaluate costs when you select services? How do you evaluate new services? These are all great questions to ask your organization. And when a company's on AWS and they're spending a lot of money, this is a great series of questions to ask them. And it's surprising, right, that how many organizations and startups in particular don't ask these questions. All right, so really in a nutshell, AWS well-architected tool, it helps you review the state of your workload and compare them with the latest architectural practices, gives you access to knowledge, delivers an action plan with step-by-step guidance, and provides a consistent process for you to review. So a lot of great things about that. And now in terms of reliability and availability, there's a great quote by the CTO of Amazon, Werner Vogel's, everything fails all the time. Yeah, I think that is pretty much the way things work. And you need to assume that that's going to happen, right? And so what is reliability? It's a measure of your system's ability to provide functionality when desired by the user. And this means everything. So, hardware, firmware, software. And then what's the probability the system will function? And what's the mean time between failures, or MTBF, total time in service divided by the number of failures. So you can see this with a car, right? There's brakes, ignition, cooling. That's the system. So understanding reliability metrics, a system's brought online, what's the mean time between failures, mean time to repair. These are all important things to be aware of. And so normal operating time, a percentage of uptime, for example, 99.9 would mean, overtime for 1 year. Number of nines, 5 nines means 99.999% available. So high availability, this is when a system can withstand some measure of degradation. And also downtime is minimized and there's minimal human intervention. So you can't call yourself highly available if humans are clicking buttons, right? If it basically should be minimal, if any, for a high available system. The availability tiers, you'll see this a lot with SLAs, service level agreements, that if it's 99% available, it means that it may go out for 3 days per year. And that may be okay for things like batch processing. But if it's an internal tool, maybe you're okay with it being down only about like 8 hours a year, like, I don't know, project management tool. You can say, point of sale system, maybe it's down 4 hours per year, so it'd be 99.95. There would be a video system, like a streaming service. Maybe that would be 99.99, so 52 minutes a year. And then if it's an ATM or telecommunications, it might be 5 minutes per year. So that would be 99.999%. So it's important to know about the nines. Factors that influence the availability would be fault tolerance. So, do you have the redundancy built in, scalability, recoverability? And then there's also this trusted advisor. It is actually a very good idea if you're using AWS to look at this periodically. It tells you things like cost, performance, security, fault tolerance, service limits, and these will actually give you some pointers on like things to fix. So yeah, why not take a look at it? All right, so that takes us through the architecture. The last one that I'm going to cover for today, and then we'll have Cloud Practitioner wrapped up, and I'll move on to other things next week, is automating scaling and monitoring. So let's go through here and just talk about it real quick. So what we're going to talk about here is things like load balancing, which I think is very confusing to many people. Like, hey, what is load balancing? In a nutshell, it's designing for failure. And so the idea is that you distribute the traffic across multiple machines so that because again, you're assuming things will fail or that needs to be scaled up. And so, there's types of load balancers. There's an application load balancer, and this would be HTTP or HTTPS. That's like web traffic, either unencrypted or encrypted. And this is operating at OSI model layer 7. We covered that earlier, the network OSI model layers. There's network load balancer. This would be TCP, UDP, TLS traffic. So you hear about these different network level protocols. TCP is the one that most people use, and it's got this exponential back off into it, where if the traffic starts slowing down, then the sender will start slowing down the amount of traffic. UDP is like fire and forget. So basically you just fire as much as you want. So UDP can be faster, and that's why some game companies will use the UDP protocol, and that operates at layer 4. The previous generation is called Classic, and that would be HTTP, HTTPS, TCP, and SSL, and that operates at both application and transport layers. So it is important to know the names of these load balancers for certification exams, and then what they actually do. So how does load balancing work? With an application load balancer, basically it can register targets in a target group, and then it can figure out whether the machines that are serving out the traffic are healthy. If they're healthy, it'll serve out the load. So elastic load balancing use cases would be highly available and fault-tolerant applications, containerized environments, and also elasticity and scalability, so invoking a Lambda function over HTTPS. And so let's move on now to load balancer monitoring. So how do you know what's happening in a load balancer? So Amazon CloudWatch metrics are used to verify the systems is performing. Access logs, so you can also go through here and just see what's actually happening. And then CloudTrail, and this captures like who is going into the API interactions. And this is really like a security auditing approach. Now, CloudWatch is the monitoring service that you can interact with. And in particular, what it does is it monitors AWS resources like EC2, for example, or S3, also applications that run on AWS. It can collect both standard metrics like CPU, memory, and also custom metrics. It can send alarms. So this would be something common. Maybe you're having performance issues or CPU, is starting to spike. You could have some kind of a notification sent, and maybe it can go to your phone, or it could go to an email. And then you have events. This is rules that match changes. So what are the alarms? This is, again, very straightforward thing that I think is recommended, is to create an alarm based on some, either static threshold, anomaly detection, or a metric math expression. And you can do anything from namespace, metric, statistic, period. So probably the simplest thing to think about would be, if the CPU is over 75% for 5 minutes, do something, right? Send a notification. And in fact, that's one of the examples they give. If average CPU utilization is 60% for 5 minutes, or if the number of simultaneous connections to a database is over 10 for a minute, do something, right? These are all the kind of things that you would do with CloudWatch alarms. So what about EC2 auto scaling? Why is it so important? The idea here is that you don't want to overscale something at the beginning because you're going to pay for things you don't need. And in the case of auto scaling, it helps you maintain the availability. It also allows you to automatically add and remove instances. It detects that when there's a problem, like, randomly things can go wrong even on just one host. And so this provides different options like manual, scheduled, dynamic, or on demand, or predictive scaling. So typical traffic at a place like Amazon could be things like, it's peaks up and down. And so the provisioned capacity would be wasted, right? Instead, it would be better to actually, match what's happening automatically. And you could do this with like an auto scaling group that collects the instances and treats them as a logical group. And you would have a minimum size and desired capacity, and you launch the extra ones when you need them. And then you scale them back out when you don't. And so you have scaling out versus scaling in. So you have a base config, maybe a couple instances. To scale out, you would launch, let's say, another node, and you have 3 virtual machines running. To scale back in, this would just terminate that instance and come back. So that is the ideal scenario, is that your system is able to actually scale up and down without humans being there. If you don't have this, you have a poor AWS architecture. So how does EC2 auto scaling work? You have a launch config, AMI, instance type, role, security group, EBS, and you go through and you do health checks. And typically that's the typical way you do it. And you could actually dynamically scale up and down. I think that's probably also the most typical way. So dynamic scaling, an easy one would be, you would just put on the auto scaling group, if average CPU is over 60% for 5 minutes, add another node. So AWS auto scaling will monitor your application and automatically adjust capacity, and it will provide a simple interface for it. So it works with EC2, container service, DynamoDB, Aurora, and in general, the scenario here is that you don't need to build out this stuff yourself. You can actually try that out. So, in a nutshell, I guess the main thing I'll stop with is that, when you're building things out with AWS, what's important to be aware of is that probably one of the easiest things to mess up is that you have to manually go through and do things with humans. And if you have humans clicking buttons, you're setting yourself up for failure. I think that's probably the biggest takeaway that I would recommend. And somebody in a question here said, I love what you're doing. When you're answering questions, could you please answer if I should be doing projects along with videos? Yeah, I would say in general with with things like learning to do cloud computing, the more projects you can do, the better. And in particular, it's just a habit to get into, is like building solutions with AWS. I would say any of the labs that you can get access to, build them, try different services, use a cloud shell. The more abilities you have to play around with things, I think the better you're going to get at cloud computing. So just to kind of wrap up everything I've covered the last few weeks with AWS Cloud Practitioner certification, is that, going through, taking the practice exam, making sure that you have a notepad or like a Google Doc or a Word doc or whatever, that you write down everything that appears in the white papers that they recommend. Like if you see a term that you don't know about, like application load balancer, I would put it into a document, look up the definition for it, write it down. And if you just do that alone as a way to study for the exam, that's probably one of the most effective techniques, is make sure you understand the terminology, write it down, and then you're gonna be able to master that terminology. You won't feel confused when you're on the exam. Second, I would say, is that build out these projects, as many projects as you can that are related to the exam you're studying. It's just going to help you understand what that service is going to do. Okay, well, that's probably a good time to kick off for the day. And then next week, I'm going to cover a little bit more into application development, probably take a break for a couple weeks before we go into the Solutions Architect exam. But I will see you all next week at 3 p.m. Eastern Time. All right, talk to you later. Bye.